Okay, so Assalamu alaikum everyone, and welcome you all to the second part of our third workshop, which is conducted by Syed Rameel, who will teach us today that how can we implement practically data visualization via Python. Throughout this session, we will go over various concepts, and as you know, as you have heard yesterday as well, the knowledge that Ramil has regarding this field, and he has been through various and different kind of projects. So we will see the glimpse of all of that experience in this teaching today as well. So looking forward to this session with Ramil. So over to you, Ramil, and you can conduct this workshop in the manner that you feel is fit for all of us. Over to you.
Uh, hello everyone. Today the workshop is actually regarding the visualization techniques, different visualizations techniques that you can use in Python, and more importantly, my focus would be that where can you use these visualization techniques, which areas are important for and where these visualization techniques can be helpful to you. Usually what we do is we learn that there are different kind of visualization techniques. You can draw these kind of plots and whatnot, but how do they actually help us to find out to extract information, and and at what stages of a project would you be using those visualizations? So Numan, I want to share my screen, so if you can allow me that.
Yes, Ramil, you have the rights now.
Thank you. So let me know when you guys can see my screen. On chat, maybe someone can type in that if it's visible. Okay, thanks. So today we are going to be going through the with different visualization techniques that are present different libraries. We are going to be mainly looking at two libraries. One is matplotlib, which is the most commonly used library in Python for visualization techniques. Other is some examples from Seaborn, and if we have ample time, I might touch Plotly as well. These are very powerful libraries in Python. They're open source and freely available for different uh, and they provide you with various visualization options, from scatter plots to box plots and various different kind of plots, which provide different sort of information to you. So first thing is, why do we actually need visualizations? So visualizations are mainly basically a summary of your data sets. In simple words, it summarizes your data set. And where, I mean, whatever area you're focusing on, maybe relations between features or your results, or presenting the results to the client, or finding certain variances or similarities between different features, or or in deciding what to do next, or which actually feature differentiates the different classes, for all those purposes. But these are the different purposes, but eventually what you're doing is you're looking your whole data set in a from a canvas, from a from upper, you have an upper view of it, a holistic view of your whole data. You don't have to go through different each data, each record. You don't have to look at each record separately. You want to see a overall overview, a overall picture, which is easy to explain as well, and it is self-explanatory, so you use these graphs. And usually for graphs, the more powerful library is a more powerful language is R. I mean, data scientists are usually using R and Python for different work, and Python is most commonly used. When it comes to visualization, Python has many features and is easily readily available and can implement a lot of things very easily. When it comes to visualization, Python is extremely strong, but but if you want to do some in-depth visualizations and very you have to make some very pretty reports, R is usually used because it provides much higher capabilities. So apart from that, there are different tools that we I think we touched in the last class also, like Tableau. They have very strong visualization, and even those features there where you just plug in your data and they'll suggest you the best possible visualizations. And even if you do not want to code, and you do not like coding enough, and you want to simply just through drag and drop make some pretty visualizations and dashboards actually. So those are really good tools for that. Our focus today would be mainly on the Python visualizations, various kind of visualizations. Most importantly and most commonly used visualization library is Matplotlib. When you install Anaconda, it is usually Anaconda Python. It is usually embedded in it. But if it is not, you can simply install it using the conda install matplotlib command. Once it's installed, or I mean, or if you do not using Anaconda, then you can use pip install matplotlib. Pip is the common tool for installing Python packages. Now after that, as once you've installed it, you can import the library through this. It's not just import matplotlib. You have to import import it like this: matplotlib.pyplot.splt. This command, matplotlib inline, uh, does anyone have any idea that what does this actually mean in Python notebooks, this particular sign? Okay, so anyone who can tell that what this sign means? The percentage sign, yeah. When do we use? I mean, where is this used? I know you guys might need. You guys might know what matplotlib inline does, but this sign in general, you'll only find this sign in notebooks. You won't find that in Python codes. And once there, I'll just connect a bit with when you're deploying your information and you're deploying your codes, you won't be having this percentage sign. Placeholder might be the right word. It's basically configuration. It's basically setting up the configuration of Python notebooks. So basically, this actually tells Python inline that this sign followed by Python matplotlib inline tells that the configuration of matplotlib for this Jupyter notebook is set that the visualization needs to be printed below the cell. By default, I believe it's not inline. What happens is it's saved. It comes out of the it opens another window and shows you the graph that is made. So to see the graph in the notebook, this matplotlib inline uh, command is used. And this and with a percentage sign, because it's a configuration setting for your Python notebook. Starting from a very simple example, we create two simple arrays and we have to create a graph. This kind of a graph can be used to see various trend lines, various ranges, or various that how is the data? Is it are these two fields linearly connected, or are these fields they have some kind of a relation or not at all? So these kind of this kind of initially we'll just use these two arrays, and let's say we are comparing two features and we are looking at how is one feature related to another. Let's say we want to draw time of hours in a day along with number of passengers, I mean just making it up, or number of people in a hotel at and different hours. So you want to see that how your you have two arrays and you want to see that how what is the relation between these two, what kind of a graph you can make it. It's very simple. PLT we imported above. That PLT dot plot, given the x-axis, given the y-axis, and the color. Here y means yellow color. Yellow color, it can be changed to any. And one, if you press Shift Tab over here, it will actually tell you that what are the different options available to you. Wait, I think I haven't imported it. Okay, yeah. Wait. See, Shift Tab, you can get to know the whole, you have the whole help in front of you. It tells you a summary that what does this function do, plot y versus x-axis, xy, and what are the things that it takes. You have all the help available to you, like width, marker size, line width. You can, there is a lot of uh, customization that you can do. Uh, if your data, and then yes, two, if you have 2D arrays, then how you can implement it, what does it need, or you get all kind of help from here. So pressing Shift Tab on any function will get you the information, like this one here, x lab, x label, y label, although they are self-explanatory. But in case you, for any function, if you want to know that what are the arguments taken, and if an error is being thrown, then Shift Tab really helps you in finding help in your notebooks. So this is a very simple. Here we generated two different arrays. One is x-axis from 0 to 10. Y-axis is the square. This is the square. This is a function which is actually taking the square of x. Taking the square of x, you have that you have the values of the square of each number, and then you simply plot it. Here it goes. It's from 0 to 100. Uh, and this is as simple as this: plt dot plot x label, y label, title, and show. If you want to visualize it, you want a different size, you can play around with this and use the Shift Tab command, that what options will be needed, so you can improvise it and see different things. And so apart from it, you can see multiple graphs at the same time. So this comes in handy when you are checking out one feature being related to other different or other features. You can use this kind of command, which is subplot. Subplot is the which it gives you the by it gives you the size of each box, and it tells you uh, that I mean, if you it gives you the size of each box, and it you can change the details of it, and it tells you what are the argument that it needs, which includes you can, I mean, easily press the Shift Tab button. It will guide you through it, that what are the things that are needed. And you can, using the, for here we use the plot command. Below we use the subplot command. The subplot command helps you plot multiple graphs at the same time. You see the x, y, r. This is the previous graph we used. R is the red color. We used in the same data, x and y data set. The same data we are using here. A 2 by 2 means you can it's the size of the box with and this is the second plot, subplot 2, 1 and 2. Here you draw here you're drawing it y against the x-axis, so it's a whole transposition of it, and a different graph. Similarly, if you want to see both of those lines in one graph, you can simply hide this line, and it will show you these two graphs in one box, like you can see in this particular example below. But let's say this is one example where you plot it at the same, basically at the same address. You did not change the address of the graph, and it plotted you two lines instead of one. So I in the same graph. So the visualizations are usually as simple as this plt.plot, where it mainly helps you are three stages. One, when you have at the feature engineering level. Yesterday we discussed the crisp DM methodology, so where there you can say at the just before modeling data preparation stage, where you can find that what are the variances, and which features are actually relating to what you want to do. We discussed one example yesterday about churn. So let's say you have different features, different features like total time of call and whatnot. You can see that which features would be helpful, or how they can help you finding different, if they are related or not, if they provide any input, do they, are they linked, or are they not. uh, One example, let me hold on. One example for that, uh, this kind of a feature of feature engineering, visualizations being used for feature engineering. Just give me a second, I'll share my screen again. Let me open up the example for you guys. Yeah. So here in this visualization, you see this was a data set, where one uses, where we are checking that, the purpose of the data set is to see that which to predict, to learn and then predict that which of these people will they pay off their loan, or will they go to collection, and they will need it to be collected. Now that this data set had a feature of gender, and just wanted to check the related to that, how many what kind of amount, what's the status of loans, and what kind of, and at what kind of amount these kind of, these gender are, these gender how these features are related: gender, principal amount of loan, and their status. This is a graph where it actually tells you that male have taken larger amount of loans, where the collection has been comparatively comparatively low, comparatively higher as compared to, and the paid off are, although both the paid off are higher, but in females the rate of paid off is much higher when the principal is touching 800 and 1000, and that's kind of explaining you this graph. Similarly, this graph are actually phase grids. This is a Seaborn library being used here. We'll touch those libraries and those kind of graphs there too, but I just wanted to uh, explain that how this visualization help us find insights from the data. uh, so here you can see that, here we had the gender of the age along with the gender and the uh, and the amount. So it tells you that people between 20 to 30 are the ones that are taking, have high incident of loan not being paid off. Where over here, if you see at 20 to 30, that, and you can see that here gender does not play a role, because you can see, if you do it by ratios, it's a similar ratio you can see in the females also. So it explains you this. So these are just, I mean, examples of finding out that what feature can help you. Does male female, do you have to include male and female, the gender feature in your data set or not? Does it provide you some kind of insight, or does it not? And Does age provide you some kind of insight or not? Here we can clearly see that age uh, clearly provides you some kind of an insight, where where you see that between 20s and 30s the ratio of people paying not paying off loans are much higher. So these are different. So this is so this is a place where you can use this visualization for feature engineering, and it's most commonly used for this purpose. Going back to our notebook, uh, at different sort of visualizations. So here you see the yeah. So here you see this is the, so now these are two very simplistic graphs where plt dot subplot, we saw plt dot plot and plt dot subplot. Subplot is for multiple graphs and one graph at two or multiple graphs or two various or smaller graphs or two different places with their size being provided. And plt dot plot have its open dimensions, although you can set the dimensions for that too, but usually it's as simple as this, that plt dot plot x and y. So similarly, now we'll jump to one other level, which is the where we use more formal object oriented method to create figure objects and then just call methods or attributes of that object. The approach is nicer when dealing with a canvas that has multiple plots on it. Here you have to like, let's say you have to, this is a simple graph of plotting it on you have added this is a simple graph where you have suggested the uh, figure. First you've got the figure and empty canvas. The empty canvas is actually where you do not have these graphs present here. Wait a second, let me, this is an example, this is will be called an empty canvas. Here we'll come to this, here we have multiple empty canvas, but just if you want to create this one empty canvas, you get the figure out, and in those figure you can actually pinpoint the axis and their exact places where you want to create those graphs. Like here we had in that figure we wanted two graphs to be placed. Let's start with the simpler one. We wanted one graph to be placed, and these are the settings: left, bottom, width and height. This is how much I mean it creates the dimensions of the box. You create your data set and simply plot it with the same function that we used above, dot plot. Here we are using axis because axis we first got the figure, and from the figure we got out a set of axes that will be needed in which we want the graph to be built. And based on that we built our graph based on the square roots from 0 to 10 and the square roots of those functions, and a graph is built. Notice one more thing. Here here we had a plt dot show. uh, can anyone tell me what would have happened if there is no plt dot show? So in this particular case, PLT, no, okay, see, let's see if there is no graph or not. There is still a graph. So PLT dot show did actually still show you a graph. There was still something. So why is that? So PL, if you see in these two boxes, there isn't any is there in there also there isn't any plt dot show, but there you can still see the graphs being plotted. So basically what happens is that in Jupyter notebook, the whatever the last command is, it is thrown back as a display, like let's say in b is equals to 3, I do not have to write b and it will oh sorry, you do not actually have to do this, and it will show you, it will print b where over here. If it's just this, nothing, you do not need the print command. So plt2, so without the plt dot show also you can easily see the graphs, but if it's the last line, if like let's say there is a whole code here after this plt, you might not it might not display the graph. So for in that case you might have to have a plt dot show in between, so that's why it's not needed here. Similarly, here you have the x's, you set the x level, y label. We just this was just one graph we had to make, but why to go to figures? Why to get the whole canvas out and then create something inside it? Why to do that? You need to do that if you want to see multiple graphs at different positions, or at the if two graphs embedded in the same position, or maybe three different canvases and comparing three different kind of graphs here. So for that you get the figure out, and then you have more power of customization, uh, like this one. you got the plane figure out, and here you created two different axes. Not, this is one axis, x label, y axis and x axis. And here in the second one we added another axis, which was this, if you see, the size actually complements to the length, width, height, and the graph needs to be made. Here we are telling the position inside the figure, that where to place that this particular graph. We had two different data sets, we plotted it, and a line was created and something was placed inside this particular graph at these particular places. So this actually the figure if part actually gives you more control to the more control to you, where you can implement the graphs more in a more customized way. You might at this level where you guys are, I don't know if you guys would need this much this kind of a graph. And to be honest, I haven't used this kind of a graph till now though. But this is a possibility. So I don't know, maybe in the future I might also have to use it. So just to explain that how the figure incorporates the graphs, and how why the figure is used, and how much customization you can get. I mean, you can have, if you change these x's, uh, first we have to know which one is left, right, and all. If we change this number, this graph can be placed at different locations. So like, let's say we can make this 0. 0.4. Wait, this is 2. Okay, so it says y1 is not defined. Where is y1? Oh, okay. So y1 was basically here. The data is being carried forward. And if you see, this was the left, this was the variable for the left, and the graph has moved much more to the left. Similarly, changing it to 9, the graph moved up. Let's change it to at a position below, the graph moved down. And it and this is, you can place it anywhere you want. So this kind of graphs can be needed, can be, I mean, in the various use cases it can be needed. So now moving forward to subplots. We discussed subplots above also. The subplots plots object will act as a more automatic access manager. What happens here is, here you had, when you got the figure out, you got much more control over where you want to place these different figures. uh, in subplots, it does that kind of automatically for you. You do not have to do many different kind of different kind of settings, or like hit and try that where should the other graph be. Like, this is a simple example, but here is a more complex example where plt.subplot, we got rows 1 columns 3. And by simply right shift tab, you can see that what does this function do. Makes it convenient to create common layout of subplots, including the enclosing figure object, and what are the parameters it takes: number of rows and number of columns as an integer. It takes those as the integer input, where here it says 1 row and 3 columns. So now you have 3 different graphs of I mean, this value is 0 to 1. It has decided the size automatically by, as per how he said he saw fit. So now if we do this to 2 rows and 3 columns, it would create 6 different graphs here. If you see, the size is automatically fixed. It's the same size as of this plot, and the subplot actually divided that into multiple sections. In this case, six different sections. So in each axis, yeah. So this is interesting. Now we have axis information. Axis 1, 2, 3, 4, 5, 6. These are different. These are the 6 axes. These are the different graphs that through axis you can access each graph, and input your data if your data is different for each graph. If it is the same arrays, different configuration, you'll have a better way to do it. But let's say your data is different, you can use these axes to fill in these different data. Figure is this one whole figure actually. Axes provide you, axes are the like here we had two axes, and where we had to tell the size and where and their exact positions to be displayed. Here we didn't give any of this left, right, bottom up numbers. We just gave the number of columns and the number of rows we require. Based on that, we will be able to display it. So going back to how it was, which was one row and three columns. Here for each axis, we plotted the same. Here in a loop, we plotted the same data. Like we didn't change the data much. It's for each axis, for x and axis, it will first pick this one, then this one, and this one, and plot x and y with in blue being the color, and set x label, y label, and title. You can even set a legend if you require, and it will show you, and you can place it anywhere you want. So this will simply display this kind of a graph which shows you the visualization. So now, if you like in the previous graph which I saw, which we were looking at for feature engineering of the loan payoff example, there you see those kind of graphs were also made through these axes. These axes basically help you how to display how I mean the how many graphs you need, and gives you much more control, seeing much more summary of your information and much more insights, providing you much more insights. But the interesting cheese is the interesting thing here is the this whole object is printed, is visualized through figure. That's the main thing. These axes are here. If you see, we created this subplots, and subplots return two things. One is the figure and the other is the axis. Figure is this whole overall area, the whole canvas that you get, and axes are the different axes that you create inside. You will set the axis, but overall you will view the figure. I don't think you cannot view the axis inside individually. You will always view the whole figure. This is another example. Now, a common issue, yes, there is a common issue with matplotlib, which is overlapping subplots of figures. So sometimes when you are displaying it, they can overlap it. Here, if you see, these numbers are kind of being overlapped with this first figure. Similarly over here. So there are solutions of setting them right, where you can use tight layout or tight layout method, which automatically adjusts the positions of the axis on the figure so that there is no overlapping. And I mean, if you guys have worked on Word documents also, and if you insert a figure and you right click on it, and there are different options. If you get that to tight, it sets it gives you, an option to place it exactly where uh, at an exact position where you want. So this is a similar kind of a concept. That's why the wording is the wording also explains it, and that's exactly what it is doing. By tight layout, it has just created, though it creates these overlapping, and makes it much neater for your results. Let's put a figure dot tight layout here and to see what's the difference exactly. Didn't it show this time? Ah. So tight layout actually, I hope you guys can see the difference clearly, that by setting it to tight layout, it gave the distances, it provided the distances over here. Same thing, it's being two rows, and these graphs are being made based on these four different graphs are being made. So you can also matplotlib also allows the aspect ratio and figure size to be specified when the figure object is created. So here, I mean, here if you see, we were just given rows and columns, and here above we were telling the position of where the box needs to be. But now at the third level, What we are doing is we will be changing the size of our graph. We can actually spread it out, and I mean do a lot of things. I mean with the it provides you bit more control. Like here plt.figure, the size has been changed 8 by 4 with DPI 100. DPI is the dots per inch, which actually helps you in sharpening of the image, that how sharp the image would be. If you press shift tab, you'll again get to see this different things, different classification, and it will help you much make the graphs much easier and faster. Because here like there are some settings we didn't try, like edge color. You can even change the color of your edges, and face color. I mean, you can have a lot of control over it. Plt.figure with the figure size, which takes two float in as input and gives you the size of that figure. So here this is the width and 4 is the height. Let's see what will happen if we do it 8 by 8. Okay, so here we have 12 by 3. So let's move forward. Here we have now, here in the subplots, we are taking fig size as an input because subplots allows us to do that. uh, Along with rows and columns, we can even provide the fixed size as an input, and it will display this graph. Similarly, if you do this, change it to 8, you will see a much larger graph. So based on your requirement, you can change these graphs and see different kind of visualization. Now let's say you want to get this visualization out and save it into a file, or move it or share it with your team members or something. What you can do is you can just simply save figure. You can specify the resolution if you want. If not, it will save by an automated by a default value or whatever the DPI of the image is. And it will save the image with the file name in the same directory where your notebook is in uh, through this command save figure. So once you have finalized your graphs, you've built your graphs, and you want to present it to uh, to the the clients, or put it in your documents, or print it out or whatever, you can simply use this command to get the image out of the notebook. And you can save it in various formats here: PNG, JPG, even a PDF. You can even save it in a PDF and get that out. uh, so this is one example I'd like to take. One example I'd like to show from my work again. It's a real life example where we took the graphs out, we were calculating accuracies, and we were testing it out, and uh, we wanted to see how far away we are from our real values. Let me show you a graph from real world. So here, can anybody explain by looking at this that what this graph might be telling? What is this graph about? What information is it giving you? Make a guess, anyone, if uh, what information this graphs actually gives you. So basically, what this graph is actually telling is, what we had to do was we had to make a model which predicted which predicted permeability in a rock through the image. So it was a regression problem. We had to predict the permeability from certain features. So now that, if you understand it, you're not predicting a class. It's not a one-to-one match that you're right or you're wrong. Here the problem gets different. It's a regression problem, and you have to see how far away you are from the real value. or from what from a real value, and this is actually called mean absolute error. Here you will see different kind of MAE, mean absolute error, that on average I'm this much away from the real place, real graph. So this graph actually was made that this all of these points, if they are exactly on the line, that means that this is on the x-axis you have the measured value, the real value. On the y-axis you have the predicted value. And what it is actually showing is that how far away from the measured value is the predicted value. Now this one is actually quite wrong. This one is actually quite wrong. The ones which are on the line are the right ones, because they were kind of spot on. The difference between the predicted value and the measured value was almost none in these cases. So this represents my whole data set. It tells me my accuracy, that how accurate I am, and seeing the spread I get to know that. And obviously these are different, the colors are the colors are actually showing you different classes. So it tells me that this particular class isn't going that well, while in the middle this class is acceptable. It is acceptable. I need to work here, because here my predicted values are much higher than the real values, and in these cases they're much lower. Here it's an acceptable difference. In certain points these might be the anomalies and and might not need to be dealt with, but in certain points they are away. But overall in all they're in good shape. Similarly for this class, I get to know they're almost at the right place, but here it tells me that this is the class I need to focus on, because my predicted values are much away from my my real values, uh, which I really, from the measured value which I wanted to show. This this is actually, these points you can easily create through scatter plot. This is a scatter plot where you just simply put in this I mean, here is a function, a scatter plot and a line where it shows you the data points and all. This was, I mean, another example of different rock types, and I was looking at the original value and the predicted value, how far they are, and the lighter ones is the training set. So I needed to explain. The interesting part was I needed to explain to the client that why are these values away. So now he gave me a test set. He asked me that, okay, my real value is this. This is the predicted value. Why they are away? So how to explain this to the client? What I did was I put on in the shadows, the lighter ones you see, I put in the training data set. I put in my predicted value and the original ones, just to explain to him that the training data set he gave actually kind of fitted the results, because I was quite sure that, based on the training data, it is it will, obviously it can't make the things up, so it will give results through whatever it was in the training set. So here whatever was in the training set, when I visualized it, and by the way there were only two features, so it saved my life. I mean, two, based on one feature we were predicting the other, and if it was a regression problem. So that's why this visualization. If it had been 3D, it would have been different. Similarly 4D, I might not have been able to visualize it. I'll have to show multiple graphs, but till the 3D level we can obviously visualize these particular graphs. Here it explains that this was the original value, this was the predicted value. While with these kind of values in the training data, in your historical data, the results were like this. For various classes I did that and showed them the reasons. So this is one of the live examples of real world examples of visualization that we use in our work almost every other day. So moving forward from mat it's still okay, it's still plot lib. Yeah, now here you can add legends. Legends are these keys, you can say, which explain your data, that what is the blue line, what is the red line, and it explains you beautifully here that blue line is this cubed values, and red line is the squared values. So what exactly the code is doing, you are getting your figure out, and based on the figure you're adding an axis on the position. 0011 means actually the whole box, because if you see the numbers previously, they were in points, because the maximum they can go to is 1111, which is the size of the which is that will mean the whole overall canvas. Here we needed a smaller box. We changed the size to a smaller boxes. Over here, this example shows 0011, which is actually the complete size of the figure. Based on that, we are able to plot I mean we plot the data. This is x-axis, this should be the values on the x-axis, these are the values on the y-axis, and red color, blue color label, you have assigned these label to these two graphs. This graph x dot plot means a x dot at x squared, and this one means x cubed, and it actually showed you uh, it showed you different kind of two different visualizations and the legend. And you can change the position of the legend. Here you see location 1, location 0, you can change the location to anything. Here you can see the values that it should cater for. uh, let's change the location to 1. It goes here. 2 will most surely go to the bottom. Okay, 2 came it, yeah, 3 got it to the bottom, and 4 got it here. So 0 and 0 kind of 0 and 0 actually, yeah, 0 actually looks for the best possible location. Like if the graph would have been going here, 0 would have meant that the best place for the legend is to be over here. I think that's the concept behind 0, but you guys uh, uh, please confirm. But I'm quite, if I remember correctly, that's the purpose of 0. Yeah, best for x is upper right for figures. So the strings, you can even give it in the strings form: upper right, upper center, lower center, center left, center right. Or you can give, and or even the numerical. Yeah, 0 means the best one, the best possible one, 0. Similarly, here is are the your values till 10. Center is 10, upper center 9, lower center 8. Wherever you want to place your legend, you can place it by giving the numbers. So this is another example where location of the plot is being changed, which we just discussed. Yeah, so now coming forward to different kinds of lines. In previous graphs, what you saw was we were giving R and B to just tell what colors to use for the graph, for what colors to use for the line. Uh, Here we are giving something different. If you see here, we have in the same data, same functions. We have given this as input to tell that, plot the points, and it should be a complete one, a jotted line. To this explains that the color should be green, and it should be a dashed line. So that's how it visualized it. That's how it showed you the graphs. uh, Based on visualization, based on how you wanted that to be seen. And if you see, you'll again find a lot of help here, if you want to visualize it in a different way, which also includes one thing. Yeah, what are the different options? Here you can see these are, we use these two options. It can be, you can use a lot of other options, and you can change the style of the line, and these are all the styles that are available uh, to be seen. And this one is actually, if you want to give a color in a very specific, an RGB code, which is red, green, blue code, and you want it to be in a specific color, you can plot it using a particular color. Here, it's a name, and alpha actually, yeah. So how, one thing I showed you in the previous notebook, that in this, how I actually did this, uh, these shaded colors at the back, that how did I got them less shaded or at the background. What I did was I used this variable, which now we will be looking at, which is alpha. Changed for the training data. I changed the values of alpha, and it went to the background. That this is a different kind of that this is the training set. It is for the green color, but some at the back end, making it a bit transparent. So that's how here, if you see, this alpha is being used for the first line, and for this particular turquoise color, and it's lighter than the other ones. If we remove this, it will obviously move to one, and you will see that this line is actually, there is a third line, I believe. There is a, no, wait, let me, yeah, it's this one. It's the third line, and it colors get darker and lighter. The shade gets lighter and darker based on the alpha variable in matplotlib plot. And this is now, the examples are getting more more in depth. These are, if you see, the code is actually the same. There isn't anything here. More features are being used. Line width is being moved from 0.25 to 2. You can see different sort of lines. These are all various sort of lines, and I hope this notebook will also be provided to you guys. And you can see that this is the different line widths are being used. Different line styles are being displayed over here, and based on that you can display various kind of data in different shades and different lights. So now we will be looking at plot range. This is, we can configure the range of the axis using the set underscore y limit and set underscore x limit method in axis object, or axis tight for automatically getting the fixed lines. So here, if you see, these are between these, we have already seen tight axis, where you get to see where it sets at the best possible position that would be used for displaying the graph. uh, Here, if you see, again, what we did was we created a 12 by 4 figure, this huge whole size of the figure, and we divided into two rows and three columns. Uh, this particular size into two rows and three columns. What we did was we plotted the, for the first one, 0 0, which is this graph, we plotted the data. We did not change the type of axis. It is how it uh, how whatever the default display is, we didn't change that, and it showed us the data in that way. In the other one, we actually did the, we displayed the tight, we used the tight methodology which we used previously, which actually finds the best way. So but default and tight axis, you wouldn't see much of a difference, because by default also it is it sets the range by itself. The range, by what do we mean by the plot range, which is these values being plotted over here. Here we had a custom range. Now y limit, we have said that the build the graph till only 60, although the data is the same for all of them. Here the data is going till 1000. But in the custom axis, what we did was we set these two parameters, that the range should be from 0 to 60, and for x-axis the range should be from 2 to 5. So so let's say you had a much larger data set, and you wanted to kind of zoom into a certain part. It is actually equivalent of zooming in, that you move the graph, you are having a zoomed in view of a particular area of the graph. Like in this case, we are more zoomed in this area, 2 to 5. We kind of zoom in over here and see the results. The other three are empty because we only set axis 0, 1, 2. Can anyone tell me that if I want this custom axis to be represented in this particular box, what should I change in the code? Any ideas, any guesses? The code looks pretty, I mean, simple to me. Here it's very decent sort of a code. What do you think? I just need this to be displayed in this particular box. So, any ideas? Any guesses? So basically, if you see that this default layer range, tight axis and custom axis, how are these being decided by they are being decided by the address being given over here. 00 meant this graph. 01 meant this graph here. This was the settings for 01. 02 meant this graph. If I change this to 1, 2, it will move one step down here. And what do I have to do for placing it over here? Now, any guesses? Yes. So we simply change it to 1, 1. And it will move the graph one step down here. Now you have the graph at this particular location. So this is how you can see multiple graphs. Coming now, we've any questions, if anyone has any questions they can post, because here now we will be moving to one other level, which is which would these are the basic graphs. Now we will be moving towards some more complex sort of graphs, and getting which includes box plots, violin plots, scatter plots, swamp plots, just an overview of those to explain what they are. So if anyone has any questions, please let me know. Post it in the chat. So no questions. Okay. Now we will be moving towards the Seaborn library. Uh, this particular library is much powerful than Plotlib. It gives you much more control, much deeper sort of graphs and more interesting graphs you can build. Matplotlib is much simpler to use. It is kind of, if you're working and if you want to do your own analysis, Matplotlib would be very good enough. You won't need much advances. If you want to display the graphs, if you want to show them in a different way and different manner, then Seaborn will be much more helpful. And there are, even in Seaborn you also get uh, options to uh, for geolocation. Like, you have the maps, you can place the maps. Based on the maps you can change the color of various areas and various things. That can be done using the Seaborn library. It provides that option also. So here, if you see, we load the iris dataset. Iris is a very common flower dataset which we use for learning purposes in data science. I hope you guys are familiar with it. It has different features like uh, let's just we can visualize the dataset also in a more raw way. Here it has a sample length, sample width, petal length, petal width, and what kind of a species this particular graph is. So this here you can, this kind of a visualization actually very easily helped you see that plot what is the petal length. For a petal length can easily differentiate between these kind of species. Setosa, if the petal length is between 1 and 2, versicolor goes up to 4, 5, and here you have the Virginica. But I mean, it's quite easy to see. So, and all the graphs. So, one thing, if you see, PLT is being used here too, although the graph is made in using Seaborn library. So, PLT is actually a complementary to Matplotlib. It just adds more details in the Matplotlib library, and the visual with PLT you will be seeing the latest graph, whatever the information PLT is keeping at that particular time, and it will be showing you that information. Let's say you do not PLT.show here, you change the graphs and all. PLT.show, whenever you PLT.show whatever the updated graph is at that time, whatever the plot is updated, it will show you at that particular place. So this was one example. The other example, now it has already there are fixed sort data sets which are very commonly used data set inside these in Seaborn. They provide this option of loading the here we are building a factor plot. So a factor plot is actually telling you that you have the, I mean, it is explaining you that which I mean, it is a mixed. It is showing you the categorical features and also a survival rate, which is a numerical feature, along with a bar in the form of a bar plot. So this is one graph showing you different what were the survival rate for the first class, second class, and third class people in the first class, in the second class, and the third class. Also, and it is separating the bars by the gender. Here the gender, here this is the male and female gender, and based on that it is showing you their survival rate. Here this is the same data, x-axis and the y-axis, and context, the background theme you can change through set context. Here in this, set context can be changed to what other option. You will see different options available set to, so I mean, it's a minute difference in these two graphs. It's more clearer. Talk is a bit more clear than poster, but however, let's say you want to, it depends on how you want to print it, how you want to show the same swamp plot that we saw earlier against the petal length. Now you can change the scale, you can change the parameter mapping that can override the value that are present in the seaborn context dictionaries, like paper. You have now here you are given male and font size, axis size, and it gives you here we are looking at a violin plot, which is I mean, it's actually showing you the total. total bill for a, it's a different data set actually. It's a complete, it's not even from iris data set, it's from some other data set where that is being given. These are common data giving you a whole insight of that complete data amount. You get much, you have a good range of these tips. And then where this plot is actually very similar to the box plot. It provides you the same information that a box plot would. And jumping to that, where is the box plot? Yeah. So here is a box plot for you, which you can total bill and tips. It shows the same thing. It actually shows where the data is centered, what's the how away. These are the, you can, one can consider these the outliers because they're much away from the standard deviation. It gives you an idea about the standard deviation, the range, the median. This is the median value here in the center. The quartile ranges, the highest and lowest values, the standard deviation, and uh, the outliers. Box plot can be really helpful in finding what's where your outliers are, and at what and what where does your data lie. And around 100 of records, it's summarizing it beautifully in just one particular graph. So this is a box plot. And then there are, based on different kind of use cases, you will be using different kind of plots. One interesting example is this log scale. So let me zero here. The same data is being, now if your data range is too huge, then it will, you can use this, you can use the log scale. You can change the scales of x scale and y scale to log, which will actually kind of reduce your values. Now this is when to use log skills. That's when to use log skills. That's when when the range of your data is 1000 and the other data is in tens, and you want to compare that data, then you will be using log scales basic in. And even in this graph here, this graph, you see these values, both of them are similar as well. These values were in 200s and Rug plots are actually very simple concept. They just draw a dash mark for every point on a univariate distribution. These are these are the building blocks of a KDE plot. So once you will be building these are box plot of a whole data. Here the data is basically these are box plot for each different day. So you see that on Saturday the average bill is also the average bill is higher. The the the, the bill can even, I mean, can go much higher, and the variance in the bill is also higher every, plus even the lower side is higher. That it kind of if this block plot shows that on Saturdays your traffic is actually much higher, because the lowest value and the highest value is above, the average bill also kind of increases for people. Because so you can find certain insights as a data scientist. You should be able to look at these graphs and should know that what are these graphs trying to say. Here on Friday you have on Thursday it looks like a weekday, and based on the weekday you have you are a working, it looks like that on a working day the range is much lower. There are certain outliers, but the overall value lie between uh, 10 to 30, while the average remains between 15, around 15. But similarly, if you go at this level, you will see that the range is different. The interquartile ranges are different, and it's growing. So on Saturdays and Sunday they are the highest. You have more bills, outliers are less, ranges are more. So you can easily tell that due to being as the holiday on holidays, the bills are higher. Similarly, this is here, instead of looking at the box, these are the box plot on a different axis. The orientation has changed. You have changed the orientation to H, where by default the orientation is, you can look at from here. There is no orientation, so it tells you that you have to create it. So they create it vertically. Here you have explicitly told them that that the orientation should be horizontal. So now it has printed total bills, tips, and sizes, as compared to different. Giving you the same exact information, but for three different features. Here you this one is a violin plot. A violin plot plays a similar role as a box and whisker plot, and usually we use box plots a lot. Violin plots, they provide the same information, and many clients don't actually even understand that. So box plot is more common one to be used. It shows a distribution of quantitative data across several levels of one or more categorical variables, such that those distributions can be compared. Unlike a box plot in which all of the plot components correspond to actual data points, the violin plot features a kernel density estimation of the underlying distribution. So this is kind of a these here you see each of these were points, data points. You were seeing a variance and mean. Based on that, here what you see is a distribution of data. This graph, total bill, and this graph are showing you the same exact information. Total bill against the days, and if you see, it's just healthier. It just tells you that this one is this one has more, it's giving you exactly the same information. But box plot, I believe, gives you information in more depth and is much nicer. These are really important graphs. The heat map, especially with covariances, it's really important. Here you see total bills. With total bills, you're in the diagonal, obviously you will have a 100% correlation. This is a this feature, heat map with on correlation, actually helps you a lot when you're in the feature engineering part, when you want to know that which features are important, which features are correlated. When two features are correlated, you drop one of those and keep one feature out of it, because you do not want a double count problem. Let's say you have you have two features which are 100% related to each other. they have the same impact. If one increases, other increases with the same ratio. If they decrease with the same ratio. Their correlation is one. So by using two features, you're doing a wrong thing in your modeling, because both of them are giving the same information and it's a bias to what they are saying. Because they're saying the same things, and we know that they say the same things, but we are now counting them as two different people. So based on that, when you look at the correlations, if the correlation is very high between certain features, you can easily drop those features. In this case, they aren't really high. It's around, they're correlated to a certain extent. Zero point 0.5 is the lowest color of tip, is with size, and size with tip, if the size is larger, the tip is more, but they're not much similar. Here the correlation is much higher. I mean, this will always be like this. These three fields will always be like this, which is because total bill with total bill will obviously we have 100% correlation. uh, Here you have the flights data. Okay, the flights data, and you can see and here the heat map is being used for a different purpose, that in which months against the years, how was the flight information. And if you see, the flights were higher in this particular, in 1990s, in August, July, they were much higher as compared to the previous months. Similarly in January, the overall information is that by year the data is increasing. The number of flights per month increase, and horizontally you can see that maybe that in June, July, and August, people travel more, they have more flights. So this is giving you an overall trend that the airline is making profits. Because the data is, if you see it horizontally, you see that everything is going good every year. If you see it vertically, you will see that you can see a pattern that on June, July, and August, the flights are more. Now here, I'd like to explain a bit off topic, but a very important concept, which is explainability of AI. Now we can get the information from here, but after this, a human mind is needed to guess that why is this the pattern. And For that, uh, I mean, even the work is being going on there, so to find out reasons automatically, the machine can explain that why, uh, what's wrong in that. And because and I mean, this is one level of explainability. The other level is, like your neural networks or your models, they just provide the answers that yes, this person will churn, or the prediction is this, 0 or 1. uh, do you cannot explain the reasons, which is a very big problem in the industry also, where especially a very big drawback for neural networks. And it's a very common question in interviews also, when it comes to neural networks, that it's a black box, and yeah, it cannot explain you the reasons that why it is predicting what it is predicting. So that's one of the drawbacks of it. Here it has divided the same data in different cluster maps: April, May, June, and same kind of clusters, 1949, 50. It looks similar, and there it's a bit more different. These all visualizations will be hopefully shared with all of you, and you guys can look into it in detail. Plus, there are other visualizations also. I was trying to get some 3D visualizations, but unfortunately, I wasn't able to get them, but maybe giving you an idea of how they might look for a 3D visualization. Let me show you guys something. So these are actually from a real project. I hope I'm able to show you something, visualization which is in 3D. So I don't have the data files. That's why the visualization is messed up. Now here, this is a 3D visualization. This is using the library Plotly. You see, I had three features: porosity, permeability, and RQI, and I had to see where 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 are the data points in them, how close they are. Wanted to explain to the client how I am finding the nearest neighbors, and based on that, I can even zoom in to certain points, look at them in through different angles, because the client wasn't able to understand it based on a 2D diagram. When I showed him in the 3D diagram, he was able to understand that okay, the point lies here and there. I don't have the points right now, but I can definitely share some code and some idea about how to build these 3D layouts with you guys. So uh, that's about it for visualizations from me. If you have any questions, uh, kindly post in the chat.
Um, thank you so much, Ramir. I just have some few questions that I was thinking you might can answer. That I've heard that this PY plot can be connected to some websites and to servers as well, so that we can use them online and this graphs can put onto some websites as well. So,
Yeah.
do you have any idea about that? How can we do that kind of visualization?
Yeah. So basically, they are available. You can do this. You can do those visualizations on. You can do those visualizations on your website. They basically, you send the data in the JSON format, and you implemented the front end. But it's better if you're designing. If you want to show the graphs on the front end, it's better to use Django and certain packages which are available, where your model does. You should always keep your front end display and your modeling and predictive whatever things you are doing separate. So what you should do is you should predict, you should do all the magic at the backend, send the data to Django framework, and use their power of visualization on web interfaces. Because Matplotlib, although you can display it, but they do not perform well at all. There are lags. They're too slow and they get stuck at many places. It's better that you use some front end libraries like high charts in JavaScript. You can there is high charts and other libraries available, but for usually that front end on a live stream isn't part of data science. If it was being done in a company, that front end would be a part of development, and data scientists would have to just give him the data through JSON or whatever the strategy is, and the developer will be responsible for developing that front end. In data science, these front ends are actually for your own self, where you visualize it, you generate certain reports and all. For front end, if you want to look at that area, you should look at Django and different packages that are available for front end visualization. So, and I see one more question: how do we decide which plot to use for the particular data set? It's not actually, the plot isn't actually uh, based on data sets. It's actually based on what information you're trying to find. Like if there are regression lines, I'll or if my problem is, as I explained, as I showed you guys, where if a problem is based on the is if it's a regression problem, you'll have a different, you'll be looking at those kind of graphs that I was showing you today. But if it's prediction problem, you might have confusion matrix. And then what you are exactly doing with the data set, are you finding correlation? You will be looking at heat maps. So more than the data set, it depends on the problem that you are trying to solve and what kind of information you are trying to extract, not just the data set. So, and there can't be any rule that for this kind of data set use this. Yeah, there can be rules that if you have numerical features or categorical features, based on that, how can you differentiate them or how you can visualize them.
Okay, thank you so much, Ramir, for so many insights. And I hope for all of our participants and for the people of our society and for everyone who would be watching these sessions online as a recorded lecture format. So I believe that it will be very beneficial for them. And to be honest with you, all of this learning was way more than what I was expecting initially. You went through each and every concept and most of the graphs that are available in Seaborn. You went over them, and I think when you were doing that matplot lab thing as well. One thing, just 2 cents that I would like to add to that is that um, uh, these matplot lab is a very customizable library, and there are a lot of options that we ourselves can add to it. But all of this that we learned today will provide you with a basic level of understanding from where you can build on your own knowledge as per your requirement. And you have to understand that what's your objective, what you want to achieve. Just as Ramil mentioned as well, it doesn't matter what dataset you are using, but what sort of problem you are trying to solve. And for those who want to watch our previous videos, even yesterday's session as well, we can share with you the link right after this session, which is a playlist of all the workshops that have been conducted up till now. So thank you so much for everyone for joining us over here, and we all would like to thank Ramil for taking our time from his busy schedule, uh, 2 days, 2 hours per day, for conducting these workshops. So we thank you, Ramil, for coming over here and giving us valuable insights.
Thanks, Sumant.
So
Just one more. It's a great the one more line I'd like to
yeah,
repeat, which I
please.
said yesterday, also, that it's a great initiative, and I was quite excited to hear about this initiative that you guys took, and was quite excited to participate in it. So, uh, mm, thank you guys, and the society also. Great credit, a lot of credit goes to you for taking such an initiative, because, as I said, that there is a difference between what to expect in the industry and what you're being taught, and you can easy with these kind of with the industry people interacting with them, you will get to know that where the difference is and where to focus on if you have to become, you have to get into the field.
Exactly, exactly. So that's the point of conducting these workshops as well, to spread the awareness in our community regarding what is required from you in the industry, in this particular field. And people like Ramil are the ones who are basically always the ones who are like pioneers in a new field. And for us in Pakistani's, data science is still a new field which is constantly evolving. So for all the participants, I would like to suggest you that uh, uh, although these are still buzzwords around us, but like slightly try to get out of these and learn as much as possible with the domain knowledge where you want to practice this data science. We will end the session over here, and Zainab has also shared the link of the channel where we have uploaded our previous videos. So thank you so much everyone for joining us over here, and take care, and thank you so much. Allah Hafiz.